In this video, we're going to talk about end behavior exponential functions. There's only a handful of questions on the content assessment that you could have where it talks about end behavior. It's something that's easy to get confused by, but hopefully this video will help you see that if you just understand a couple of things, it'll be really easy for you to answer those questions on the content assessment. So let's take a look at the graph of y equals 2 to the x. It's shown to the right. What will happen to the y values of the graph as the x values get bigger and bigger? Let's first make sure we understand this question. What will happen to the y values? The y part of the graph is up and down. In other words, what happens to the graph itself? In this case, it increases. It gets bigger and bigger and bigger as I go to the right. So what it's asking is when the x values get bigger and bigger, that's talking about going this way, going to the right, because x's get bigger on the right side. As I go out this direction, what happens to my graph? This is just going to keep getting bigger and bigger and bigger. It's going to keep going out farther and farther, up and up and up and up. It's never going to stop or turn around. That's what we're talking about when we say end behavior. What happens at the very, very ends of the graph? And on the right side, where x's get bigger and bigger, my y values will approach infinity. Now we use infinity, I could just say keeps getting bigger and bigger and bigger, but we like to be a little bit more specific and of course use numbers or symbols to represent what we're talking about in math. So infinity, that symbol represents there's no end, but it's big, keeps getting bigger and bigger. Now if I look at this next question, it's asking what will happen to the y values of the graph as the x values get smaller and smaller. So what end of the graph are they talking about here? Where x's get smaller and smaller, that's the left side of the graph. So it's asking what happens to my graph as I go to the left. They're looking for that part right there. Now you may not remember this from Algebra 1, but the way exponential functions behave is that the tail of the graph, it approaches a number, but never touches or crosses over that number. And in this case, that number is 0. The left side of the graph approaches 0. So as x values get smaller and smaller, the y values will approach 0. Why does this happen? Well, if you think about your general form of an exponential function, and you can test this out. You can use a calculator. I could explain it to you. I could get really complicated and explain to you in real detail why this happens. But if I take, let's say I've got 2, again, 2 to the x, if that's my function that we've got on that graph up there, if I put in 2 to the negative 100, you're not going to get out a negative number or 0. It's going to be a positive number, but it's going to be some really, really small decimal. Not going to be 0. I have no idea what this would be. Let's just say it's 0.000, quite a few zeros and 17. So it's really, really close to 0, but doesn't quite touch it or approach it. If I looked even out further, negative 1,000. It's still not, the answer still not going to be negative or 0. Now when you do this in a calculator, you're going to get something like, you could actually get something like this. Put this into the calculator. For the sake of time, I'm not going to actually put it in. But I could get out something that looks like this, 2.156 e negative 15. What that means, this right here, that's scientific notation. That means 2.156 times 10 to the negative 15th. That negative 15 tells me I'm going to move the decimal point 15 times to the left. 1, 2, 3, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And fill in with zeros. So holy cow, this is still a positive number, and it's not 0. So the y values approach 0 when I look on the left side of the graph because of just how the exponential function behaves when I plug in negative numbers for the exponent. Let's look at exponential decay. So the graph of y equals 1/2 to the x is shown to the right. What will happen to the y values of the graph as the x values get bigger and bigger? Again, if I'm looking as x gets bigger and bigger, I'm talking about to the right. Decay decreases from left to right. So I'm looking for that part of the graph. What does it approach? It approaches 0. So the y values approach 0. Next question. What will happen to the y values of the graph as the x values get smaller and smaller? When x values get smaller and smaller, we're talking about the left side of the graph. Left side of the graph, we're looking at that part of the function. What's happening to it? It's pointing up. The y values, again, remember the y-axis, they're getting bigger and bigger and bigger. Positive big numbers. So that means the y values approach positive infinity. Let's say, for the sake of discussion, I had an exponential function that looked like this. It's possible to get one like that. And I looked at the left side of the graph and it was pointing down. You would say that as the x values get smaller and smaller, again, looking on the left side of the graph, the y values approach not positive infinity, but negative infinity, because my graph is pointing down. And below, pointing down, that's where my y values are negative. So what I'm going to show you in the next page where I have some examples is I'm just going to draw a quick sketch. If it's exponential growth, I'm going to draw a sketch just like this. Doesn't have to be perfect, just super easy. If it's exponential decay, I'm going to draw a sketch that looks like this. So my end behavior, as I go to the right side of the graph, for growth, it approaches infinity. Left side of the graph approaches 0. Decay, right side of the graph, approaches 0. Left side of the graph approaches infinity. So if I just draw a little generic picture, that might help me answer these questions. So they want us to consider y equals 4 times 0.5 to the x. What does the value of y approach as the x values increase and approach infinity? So is this growth or decay? It's decay. It's decreasing because this base is less than 1. So here's my sketch. Decay. Decreases. Goes down from left to right. So it's asking, what does the value of y approach as the x values increase? So as x values increase, I'm looking at the right side of the graph. What is that graph doing? It's approaching 0 there. So it approaches 0. And that's it. Next one. Consider the equation y equals 2 times 5 to the x. What does the value of y approach as the x values increase and approach infinity? So this is growth. Why? Because my base is greater than 1. So here's my generic graph here. We're looking for what happens to the graph, or what happens to the y values as the x values increase. So that's looking at the right side of the graph. It's pointing up. That means it's approaching infinity, or approaches infinity. That's it. Next one. There's my function, growth or decay. It's decay because my base is less than 1. Whoa, that was weird. So it looks something like this. Goes down from left to right. What does the value of y approach as the x values increase? Again, looking at the right side of the graph. So I'm looking at that end. It's not pointing up, it's flattening out and approaching the x-axis. So that means the graph or the y values approach or approaches 0. Okay? You may not actually have a question on end behavior on the content assessment, but it's entirely possible. And if so, watching this video hopefully will help you figure out how you're supposed to answer those questions.